Okay. Okay, quadratic inequalities, two variables means we graph it. We're going to be graphing parabolas. We need a vertex and we need some other points. Do we need a ton of other points? No. And like I said, always, if you're unsure how to graph it, find your vertex and then do either a table of values. Table of values will never ever lead you wrong, unless you do your math wrong. Same rules apply for the boundaries as they did in 9.1. I'm just summarizing so that my video is complete. Okay, so picking a test point inside, outside, like I said, when we graph, it'll make more sense. Shade the region where the test point is true. Okay, so looking at this quadratic inequality, I know it's a quadratic because I have an exponent of 2. I know it's a graph because I've got two different variables. And they're x and y, so that's pretty straightforward. Okay, so the first thing I'm going to do is I am going to identify, am I going to have a dashed or solid boundary? Anybody? Anybody?
Dashed.
A dashed, because it doesn't have that equal sign. So just keep that in mind, that this is telling me that I'm going to have a dashed line. Okay, so I'm going to have a dashed line. All right, so now you've got to pull all your knowledge from chapter 3, but we've graphed parabolas in chapter 7, we've graphed parabolas in, where else have we graphed them? We graphed them everywhere, chapter 3, chapter 4, chapter 7. Did we do it in chapter 6? No. We didn't do it in 2. So 3, 4, 7. Did we do it in 8? Yeah, we did it in 8. So 3, 4, 7, 8. And now we're doing it in 9. So parabolas, we should be getting really good at graphing them at this point. So my vertex is at positive 3, 1. Because the quadratic is given to me in vertex form, so it's always the opposite sign. This one's always the real sign. So x coordinate of the vertex, y coordinate of the vertex. So how do you want to do it from here? Do you want to do a table of values, or do you want to do the quick method?
Quick or both, maybe?
Okay, let's do the table. Let's do the table of values. Okay, so when I do my table of values, when I do my x and my y, I always start with my vertex in the middle, and I'm going to pick points to the left of the vertex and to the right of the vertex. So I'm going to pick 1 and 0, and then I'm going to pick 5 and 7. Oh, that's not very good. 1 and negative 1. There, we'll see the symmetry there. Okay, do you guys know from vertex form where the y-intercept is? Okay, all right. I'm assuming you guys are all saying no. In vertex form, we can't see the y-intercept, and you would be 100% correct. The only thing that vertex form gives us is the vertex. We know that it's going to open down, and we know that it's going to be a skinny graph. We would have to expand this, multiply it through, combine like terms to get it into standard form in order to see where the y-intercept is. So just keep that in mind as well. Okay, so let's substitute some stuff in here. Let's substitute 1 in. 1 minus 3, I'm going to try to do this in my head. So 1 minus 3 is negative 2. Negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 1 is negative 7. All right, let's put negative 1 in there. So we have 4, 16. 16 times negative 2 is negative 32, so this is going to be a negative 31. Ooh, those are ugly numbers. How could we find the y-intercept? We could put a point of 0 in here if I put 0. So 9, so that'd be negative 18, so that would be negative 17 if I wanted it. So that's the y-intercept. I don't know if that interests you. Is it super important for this? Nope. And if we did our math right, if we put 5 in here, this becomes a positive 2. 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 1 is your -7. And what do you guys expect 7 to be?
-31.
Yes, -31. Right? Because these points are 2 away, these points are 4 away, so this is 4 away on this side, so you would expect the numbers to be the same, right? That symmetry should repeat itself. I think we have enough to graph. I'm probably only going to graph those, because I have no desire to go up to 20s or 30s or anything like that, so I'm going to go ahead and graph. So this is 10. This is 10, this is -10, that's -10. Now, what did I say to you guys? I said, sometimes when you do it this way, you're more likely to misplot a point. So I better follow my own advice and put, because if anybody was gonna screw up, it was definitely gonna be me. I'm just gonna put more numbers on there. And it's only because sometimes we rush through and we miss some obvious things. Okay, so I'm gonna graph, my vertex is at 3, 1. So there's my vertex, and my next point at 5 and -7, almost went in the wrong direction. So there's -7, and at 1 and -7. Oh, do you see what I just did there? What was I gonna do?
Curve in.
I definitely in my curve, that's a little steep for that, but I was just exactly, I totally forgot I had a dash line. Luckily, I can recover. Whew. All right, that could have been a disaster. So this is 3, 1, and this point here is 5 and -7. Okay, so I've labeled my 2 points, I've done my boundary, so that's good. Now we're gonna pick a test point. So now we've done our boundary, so now the test point helps us for the shaded, right? So the test point is 2, this was step 1. 1 was graphing the boundary.
For the test point, can you do it like anywhere outside of the parabola, or does it have to be on the same like if you're in the negative, so you have to do it in the negative?
Nope.
Y?
No, not at all. Yeah, it's kind of nice. Like the only time you have to use a specific test point, I'm just going to flip back to the 9.1 lesson for a second, is when you're creating the equation and you've been given the shaded region. That would be the only time that you have to pick a test point in here. When you're trying to decide where to shade, you can pick a test point anywhere you want. Okay, so here we are. So what test point are we gonna pick? Pick a good one. So when I talk about inside and outside, inside would be somewhere under the parabola, and outside would be somewhere, obviously, anywhere outside the parabola.
So we could do like 0, 0.
Perfect. I like it. Yeah. So my test point 0, 0, and we know that 0, 0 is right here. So obviously we're picking a test point outside outside my parabola. So when I talk about inside, outside, that's all I'm talking about. Just make sure, again, I'll say it, do not pick test point on the line. That's going to cause you problems. So again, we're going to sub into our equation. So 0 is less than -2 times 0 minus 3 squared plus 1. So 0 is less than we did this one, -17. Is that a true statement? Anybody?
No.
Okay, so again, takes me 2 seconds to write false, and that helps me remember things. So if this is false, that means outside the parabola is false. Everywhere outside the parabola is false. So by default, where is it true?
Inside.
Inside the parabola. So we are going to shade everywhere inside.
So if you know that it can only be other one option, you don't have to do another test point?
Nope. Again, make sure it's not sloppy, make sure your shading is obvious, and make sure it fills the parabola. If your arrows go down to here, your shading should go down to here. I don't want to see that, right? If your boundary, you need to fill your boundary. I'm not asking you to go on forever and ever, but I am asking you to make sure your boundary is filled. It's pretty easy. Like chapter 9 is just like such a nice like breath of fresh air. There's not a ton of tricks to it. There's, oh, it's pretty straightforward. Okay, we good? Can I flip the page?
Miss Callie,
Yep.
what happened to the easy non-table of values way?
Oh, you crazy kids. This is the patterned way. You ready for this?
Okay.
You ready? Okay. So, this is your pattern. So, plot the vertex. You guys can't even see that. Plot the vertex. Okay, so we're going to plot the vertex at 3, 1. And the pattern is horizontal, vertical. Okay, so we go 1 away from the vertex. Ooh, forgot an A and away. And we're going to go 1 squared times by your A value up or down. And in this case, we're going down because it's a -2. So we would go 1 away from the vertex, and then we go 1 squared times by -2. So I'd go 1 away, which would put me at 4, and I would go down to -2. And then I do the exact same thing on this side. So 1 away vertically and down, oh, that's not correct. Down -2, not to -2 point, that's not correct. I'd go down 2. So right here and right here.
What does the variable A mean?
It's your A value in vertex form. Remember, it's y equals A bracket x minus h squared plus k. Your A tells you the width of your opening, the direction of the opening. So then I would go 2 away, and it would be 2 squared times by -2. So I'd go 2 away, so now I'd be at 5, and I would be going down 8. So if I started at 1, I'd be at -7, -7. So these aren't coordinate pairs, these are direction. These are like mapping directions. So that's sometimes how I'll do it. I usually don't do the pattern method when I have an A value because I always screw it up just because I'm trying to get through it too quick. Table of values give you the actual coordinates. These give you the roadmap on how to get to your coordinates. So that to me is the quick way. I plot the points, 1 over 1 squared times A. 2 over 2 squared times A. 3 over 3 squared times A. And so you can go from there. And as you can see, I end up at the same points that we plotted before. And if I substitute, like if I want to find at 2, I substitute 2 in here, this is going to give me -1, which is that point that I plotted right there. So both methods are going to give you the exact same thing. It's just which one is more reliable for you. This is really good when you have no A values. Like when the A value is 1, it's nice and easy. It's like 1 away, 1 squared down. 2 away, 4 down. 3 away, 9 down. 4 away, 16 down, right? Like, and if the A was positive, we'd be going up. So I'm doing a bunch of hand gestures in which you can't see, but they're super impressive. I guess if you guys have me on the side, then you can see my hand gestures. Okay, so that's the quick way. Yeah. Okay, all right. And we did cover that in chapter 3, but I don't think we had enough confidence to use it at that point. But I think now with your amazing graphing ability, you guys can start getting into the tricks and the tips to make things go a little bit faster for you, because you are excellent. Okay, so this one is same thing. This tells me I have a solid line this time. My boundary is solid. This now is given to me in standard form. So I know a couple of things. I know my y-intercept is 0 and 4, because I'm in standard form. So I know that that's my y-intercept. I know that my graph opens down, and I know that it's the normal width. So those are things I know about the graph. So we need to find the vertex. So finding the vertex, you can find it 2 ways. You can, so to find the vertex, you're going to complete the square. Is everybody okay there? Somebody's got their mic on and they're hitting it. So to find the vertex, we're either going to not you, Xander, not at all. Complete the square or secret formula.
Not me.
I think that most of us are probably pretty confident with the secret formula. Everybody good if I use the secret formula? And if you don't know the secret formula by now, then really have a good understanding of how to complete the square. So I'm going to actually do this one in my head because it's pretty easy. This is going to be x is equal to 1. So that is the x coordinate of my vertex. And now to get the y coordinate, I substitute it back into the equation. So -1 plus 2 is 1. So this is going to be 5. So now let's try to use that pattern. And the reason why I'm going to jump to the pattern here is because my a value is -1. So it's nice and easy to do. So 10, 10, -10, -10. I always, like when I graph, I usually lay those down first or make a decision about my increments. And then I go back and put in the other ones.
For the y vertex,
Yep.
because it's -x squared, I don't know how you got 5 this well.
Okay, so y equals negative, we have a +1 squared plus 2x, 2 times 1 plus 4. So we're going to have a -1 plus 2 plus 4.
So it's a -1 then.
Right, because the negative isn't inside the bracket. Remember that this only gets applied to the x. So I'm squaring the 1 and then I'm timesing it by a -1. Okay. And grab a different color. Okay, so my vertex is at 1 and 5. All right, so I'm gonna put that on there. My graph opens which way? Which way does my graph open?
Down?
Down. My graph opens down, so that -1 is telling me that my graph opens down. And guys, guys and gals, people, mathematicians, as you're going through this, like if I'm writing a 3-hour exam, sometimes you get math fatigue and you get tired, and it seems all fine when we're doing one question, but you know when you have to graph like 6 different things or you have to think really hard about something, sometimes circling the obvious or stating the obvious somewhere makes it a little bit easier. So don't feel bad about giving yourselves those helping hands or those tools, like drawing an arrow to this and writing the word down, just to help twig your memory on how to do it. There's no shame in that, especially when you're doing a long sit. Like you're looking at least 2.5 hours sitting for this grade 11 exam. So I want you all just to be okay with doing everything you can to help yourself get the best possible mark. So just have faith in your math. Okay, so I'm going to do the pattern, Basil. So the pattern was 1 away, 1 squared down, and I'm going down because of that. And I don't have to times it by a because a is 1. So 1 times anything is itself. So I'm going to go 1 away, 1 down, and 1 away this way, 1 down. Hey, look, we said our y-intercept was at 0 and 4. Look at that. My pattern plotted that point for me. So now we're going to go 2 away, and we're going to go 4 down. So we'll be at 1. And again, I'm just going on either side, like it's no big deal. I'm going to go 3 away, so 1, 2, 3. This is where I get confused. So I'm at 5, so I should be at -4. And then this would be -4. Okay, I can keep plotting points if I want to, but I think I'm good. Like I don't think I need to do any more than that. That definitely shows the solid shape of the parabola. Oh, this time I didn't screw it up. It's a solid line. Okay, got my arrows on there. I should probably label my 2 points before I forget. I'm going to do the obvious ones. I'm going to do my vertex and my y-intercept. So don't forget. Now I'm going to do my test point.
Can we do 0, 0?
Absolutely. But now 0, 0 is located inside the parabola. Just know where that point is that you picked. Do you guys notice the shape of my graph is a little wonky here? I don't know. I like the look of this side. This side was looking a little sad. Okay, so my test point is 0, 0. And I'm going to have 0 is less than -0 squared plus 2 times 0 plus 4. So 0 is less than or equal to 4. Is that a true statement?
Yes.
Yes. So that is true. So that means we are shading again inside the parabola. And you can continue it on if you want to. You don't have to. This does indicate that it goes on forever, but you don't have to, just as long as there's a significant part shaded and you filled the boundary that you have graphed. Feel free to use colored pencils. If we were in class together, I would tell you that I have colored pencils. All right. Okay, is this our last example? It is our last example. Oh, so sad when a lesson ends. But we're not done yet. Okay, a satellite dish is 60 meters in diameter and satellite dish is 60 centimeters in diameter and 20 centimeters deep. This is a tiny satellite dish, like little. Hey, when you guys think about this in your mind, when I say 60 centimeters, do you guys envision 2 rulers? Because that's what I do. Like when I think of 60 centimeters, or do you guys see a meter stick and just a little bit over half a meter stick?
I think of neither.
What?
Yeah, I just think of something that is 60 centimeters apart. I don't think the 60 centimeters for long enough to come up with an answer to this.
Yeah, I just sort of
kind of highlight the number and put in an equation with Gauss.
All right, so none of you are visualizing it in your head. Good to know. Okay, you guys are way better at stuff than I am. So like, I'm like in my head thinking, okay, this is 2 rulers. That's a really small satellite dish. I always think of the big ones on the roofs of, you know, Shaw or something like that. Okay, so now that we realize that I like to visualize things so I have a better understanding, the dish has a parabolic cross section. So if we cut that dish directly in half, it would, if we looked at it from the side, and I think we've done a parabola question like this before, it would be a perfect parabola. Locate the vertex of the parabolic cross section at the origin. Sketch the parabola that represents the dish. Determine an inequality that shows the region from which the dish can receive a signal. Got it? Now you wish you had envisioned the dish. Okay, so it says take the vertex of the parabolic cross section at the origin. So I know my dish is going to look like that. Does my dish continue on forever? Should I be using arrows? No, my dish is finite. It's going to stop, right? So it's going to stop there. So let's talk about...
Can we do it the other way around or no?
No, this one was very specific. It said locate the vertex at the origin. If I didn't give you that line, Maddie, then you could do it with like an endpoint on...
Okay, so then does that mean the arms stop at 20 then?
Ah, so we know that the height from here to here, because it says that it's deep, is 20 centimeters. And we know from here to here is 60 centimeters. 2 rulers, just in case you were wondering. But that's not going to help us. That's not going to help us. Those dimensions aren't going to help us because we need points on a coordinate plane. So we can do this though. What do we know about parabolas? What makes them beautiful?
They're symmetric.
They're symmetrical, right. And where's our vertex on this? Where's the vertex?
0, 0.
0, 0. So my vertex is at 0, 0. I know that if this is symmetrical, then this distance from here to here has to be the same as that distance from there to there. So this point's going to occur at 30 and 20. And this point here is going to occur at negative 30 and 20. Could you guys have done that on your own?
Yes.
No.
Okay.
I think so. It's just it's worded really like sciencey.
Sciencey, I know, like there's a parabolic cross section and it needs to receive a signal. Yeah, very confusing. So really the first thing we're going to do is we're going to define our boundary. You guys would agree with me? We're going to define, so if we're creating an equation, we have to define the boundary. And really all that means is make me the equation. So it's a parabola. We need to make the equation of the parabola. All right. So we know we have a vertex at 0, 0, and we have another point. You guys with me? Perfect. I like it. So y equals a bracket x minus h squared plus k. All right. So we know some information. We know an x and y value, and we know the h and k value. So this is coming from, geez Louise, I think it's coming way back from chapter 3. So if you're like, I don't remember this, fair. So we're going to fill in what we know. So we have 20 equals a bracket 30 minus 0 squared plus 0. All right, that's exciting. So 20 equals 900a. Divide by 900, divide by 900. So those will go away. 2 over 90 is 1 over 45 is a. That's definitely not my equation. That is my width of the parabola is what that is. And it also tells me the direction. So we're going to go and fill that in into that form. So that's going to be y equals positive 1/45 x. Do I have to put in the 0 zeros? We'll put them in just so you can see them. Right? So let's tighten that up, and that's going to be y equals 1/45 x squared. If you gave it to me like that, that's 100% correct. If you gave it to me like that, that's 100% correct. I find sometimes people have a hard time jumping, like losing this line and jumping right into here. Because I think sometimes we forget that this is vertex form. I know. Okay, so that tells me my boundary, but now we have to talk about, it's not just the dish. Where does the signal come into the dish? Does it happen inside the dish or outside the dish?
Inside.
Inside the dish. So this is why this is an inequality question, is because the signal is being received not just on the boundary, but everywhere in that dish, everywhere in that cup. It receives all those signals, and we get our television and all kinds of other fun stuff. Okay, so we define the boundary. Now we have to do step 2 is the inequality. So this is like that question. So step 1 was define the boundary. Step 2, we're doing the inequality part of it. So we know that this is the shaded region. So in order to do this, in order to decide what goes in there, we have to pick a test point. This is, Danica, this is where you have to pick the test point specifically in a region. Like, it has to be in the shaded part.
Can we do 0, 0?
No, because 0, 0 is on the boundary.
But the boundary's solid.
We don't know that yet. That's an argument. I'm not sure. We'll fight about that in a few minutes, Jacob. Don't worry. I still don't have an answer to this question because I don't know enough about signals and receiving them.
Can we do 0, 1?
Ooh, that's a gooder. So Danica saves the day with a 0, 1. While Jacob and I debate about satellite signals. So we picked our test point at 0, 1. Because we all agree that that's solidly inside the boundary, but not on the boundary. So we are going to fill in our equations. So we have y, fluffy cloud, 1/45 x squared. So we're going to fill in what we know. So we're going to have 1 fluffy cloud, 1/45 times by 0 squared. So 1 fluffy cloud and 0. That was a good test point that you picked. We didn't even have to do much with that 1/45. We just eliminated it. I like it. Okay, so this is where we decide on the inequality. You guys would agree that 1 is greater than 0, right?
Yes.
Yes, good job. I'm proud of you. All right, now the question is, Jacob, you're probably going to have an opinion about this. Do we include the boundary of the satellite dish?
I think so.
So you think the dish itself absorbs the signal?
Yeah.
Okay, so if the dish is included, that means that this would be greater than or equal to, because we're including the dish. Now, if you said, I disagree, I think that the dish is just a receptacle for it, and there is a pod in the middle of it that receives those, not the entire dish, that could be a basis for just using a non-equal sign there too. It's pretty cool. Like, you would have to justify it either way, but know why you're making the decision. So now we got to write our inequality. So our inequality is y is greater than or equal to 1/45 x squared. So we took our boundary, we took the equation that we found for the boundary, and then we applied the inequality that we found based on the test point. So this is the solution to the equation. Not the boundary, not the equals to. This one here is what we're looking for. Because it doesn't just include the satellite dish, it includes all this area here as well. Oh, so exciting, so exciting.